Lesson number 19, daily summary. In this lesson, we factor out the GCF and begin factoring trinomials. I will define GCF soon, its greatest common factor. Just a heads up, this demo is long. Number 1, multiply 3x by 7x minus 5. We're not going to do the box like we did last class. We're just going to distribute. So this is 21x squared minus 15x. And the next part of this says factor 21x squared minus 15x. So we have not used the word factor in this context in this class up until this point, but 21x squared minus 15x is simultaneously the question we're asked to start with here and our answer to the previous problem, and I will tell you that the answer to the factored version of this 21x squared minus 15x is just what we started the previous problem with, 3x times 7x minus 5. So what does it mean to factor? Well, the fundamental operation in this problem is subtraction. This is the subtraction of two terms. But the fundamental operation in this version is multiplication. And I will tell you that factor means turn into multiplication. So we turned a subtraction into a multiplication. That is factoring. And you've seen the word factor in a different context in math class, maybe even in this math class. Like if I said factor, I don't know, 35, you'd say, oh, 35 is really 5 times 7. And we call 5 and 7 factors of 35, right? And so what did we do? Well, we took 35 and turned it into multiplication. That's what factor means. Still means that even with x's and possibly other letters floating around, turn into multiplication. So why do we care about the factored version of things? Well, it turns out that solving certain kinds of equations becomes much easier if you have the equation in factored form. We're going to see a bunch of those later this semester, but for the next few classes anyway, we're actually not going to see context for why factoring is a good thing, but just trust me, it's going somewhere in a little while in this class. So we are going to factor this. What are we going to do here? We're going to factor this thing in the box at the bottom of the page. This guy right here. Actually, let's start with it, this one. So we're going to factor this thing right here. And I skipped over just about everything on this page. You are welcome to read through it. But like I said, this demo is long. So I'm just going to kind of jump to the shorthand version of factoring out the greatest common factor right now. But feel free to read the details up above if what we do right here does not make sense to you. So starting with this thing that I've copied at the bottom, it's highlighted there, negative 12x squared y to the 5th minus 28x to the 4th y to the 3rd plus 8x to the 3rd y to the 4th. Our goal is to look at the three terms, and I'm going to circle them in different colors here. And we are trying to figure out what the greatest common factor is in each of these three terms. Again, the terms are separated by plus signs and minus signs. And so looking at those three terms, they've got x's and they've got y's and they've got numbers in the front. And so let's first focus on the numbers in the front. I see negative 12, 28, and 8. And I'm looking for the biggest number, the greatest factor that those three numbers have in common. So hopefully just by inspection, we can see that the biggest number that goes into all of them is 4. So we're going to put a 4 right there. And then we're going to look at the x parts in all of them. I see x squared, x to the 4th, and x to the 3rd, just reading left to right. And I'm trying to take out as many x's as I possibly can, the greatest number of x's. So do they all have at least one x inside of them? Yes, they all have at least one x. Do they all have at least x squared? They do. Do they all have at least x cubed? No. This one right here does not have an x cubed in it, and you can't take out more x's than you have. So that means that the greatest common factor for the x's is x squared. I would love to take out more x's, but that first term circled in orange has only 2 x's in it, and I'm limited by that one. Let's look at the y's in each of the three terms. Again, reading left to right, y to the 5th, y to the 3rd, y to the 4th. Trying to take out as many y's as possible, but you can't take out any more y's than one of these guys has. So do they all have a y? Yes. Do they all have a y squared? Yes. Do they all have a y cubed? Yes. Do they all have a y to the 4th? No. The middle term in this case is the one that's limiting us. It has y cubed, and even though the other two terms have more y's, the middle term says you cannot take out any more than 3 y's. So we're going to put a y cubed right there. And I just want to point out there's this kind of weird thing happening. We're looking for the greatest common factor, but we end up taking out, like if you look at the x powers, there was a square and a fourth and a third, and which one ended up out in the front? It was actually the smallest of those three numbers, right? 2, 4, and 3. We took out only 2. So we're trying to take out the greatest number of x's possible, but it turns out that the greatest number of x's you can take out is the number of x's that is the smallest number of x's in any of the three terms. Okay, this thing that we've written here in black is the greatest common factor of those three circled terms, and it is going on the outside of a big set of parentheses. And in this big set of parentheses, I'm also going to put my signs. So I've got a blank space for what's left of the orange thing, and then I see a subtraction sign. And then I've got a blank space for purple, and then I see a plus sign, and then a blank space for green. So we know that whatever is on the outside here is going to distribute to these three terms. And whatever I put in these three blank spaces had better result in this original version of the problem, right? After we distribute, we better just still have what we had before, just in a different form. So let's focus on orange. I am trying to put something in this space so that when I multiply the 4x squared y cubed times whatever I put here, I get back orange. Okay, so 4 times what number will give me the negative 12? That's easy, that's negative 3. Let's look at the x's. X squared times however many x's I put here is supposed to give me back x squared. How many x's should I put right here? Well, none, because if I even put a single x there, then x squared times that x gives me x cubed, and that's more x's than I had. So we don't put any x's. This orange thing had only 2 x's to start, and they are both represented out in the front. Let's look at the y's. This y cubed multiplies by however many y's I put here, and it's supposed to give me y to the 5th. So y cubed times some number of y's gives me y to the 5th. Well, it's got to be 2 y's that I put inside of the parentheses. So that's going to be y to the 2. And as a quick check, indeed, if we multiply the 4x squared y cubed by this orange negative 3y squared, we get exactly what we have circled in orange in the front there. Okay, let's look at the thing that's circled in purple. So we know that the 4 is supposed to multiply by whatever we put here, and it's going to give us that negative, well, the 28. So 4 times what gives 28? It's 7. So I'll put a 7 there. And then I see x squared here, multiplying by however many x's we put here, and I'm supposed to get the x to the 4th that I had right there. So x squared times some x's gives me x to the 4th. I guess that's x squared, what I need to put inside there. 7x squared. And then we can look at the y's. So I have y cubed here. I'm going to put some number of y's right here and hopefully get y cubed. Well, I'm not supposed to put any y's. They're already all 3 out in the front. So this one is done. And then finally, the last piece here is supposed to give me this green circled thing. So the 4 in the front of the parentheses multiplies by what number to give me the green 8? That is a 2. X squared in the front multiplied by some number of x's to give me x to the 3rd. Well, I guess there's just a single x that we want to put there. And then finally, y cubed times some unknown number of y's to give me y to the 4th. Well, that's just a single y there. And that's our answer. We've got our greatest common factor in the front, 4x squared y to the 3rd. And then we've written down what we need in the parentheses so that after we distribute the 4x squared y to the 3rd, we get back exactly the original. And again, I'll point out factor means turn into multiplication. The original form of this problem was addition and subtraction of 3 terms. Fundamentally now, our final answer is a multiplication. It is factored. Okay, so there's lots of details typed up here, but I explained all of this when we worked through that previous example. So next up is number 8. So here's one that's tougher. Factor negative 2x cubed plus 8x squared plus 24x. First thing we need to do is factor out the greatest common factor, just like before. So I'll recopy the original problem. and then looking for the greatest common factor to put in the front. So again, I see three terms separated by plus signs and minus signs. Looking at the number parts, -2, 8, and 24. What's the biggest number that goes into all of them? That's 2. Then looking at the variable parts, I see that they all have x. So for sure, we're going to put some x's in the greatest common factor. Do they all have at least x squared? No, the last term has only x. We're limited by that last term to just take out a single x to the first power. And now we're going to undistribute to figure out what goes in the parentheses. So 2x times the first thing is supposed to give me this -2x cubed. So I don't have the negative sign, so I guess I got to put it in there. And I need x squared because I have only one x in the front, but I need to build 3 x's there. So we put the 2 missing x's in the parentheses. Next, I see a plus sign. Let's put that. This 2x is supposed to multiply by some number to give me the 8. That's a 4. And it's supposed to multiply by some x's to give me the x squared. Well, there's one x here, and so I think I need one more x here to build that x squared. X here. The next thing I see is a plus right before that 24x. So 2 times something to give 24, that's a 12. And then looking at the x's, x times some number of x's to give me x, well, no x's. So that is it right there. Okay, so we have successfully factored out the greatest common factor, and from that perspective, this problem is done. It's factored. But it turns out we can factor further. So the next goal is to factor this thing inside of the parentheses. But you might say, well, the greatest common factor of the thing in the parentheses is 1, and so there's no more greatest common factor to pull out, and I agree with that. But there's a fundamentally different kind of factoring that we're about to learn here, different from the greatest common factor. So we first pull out the greatest common factor, and then we examine what's left. And we're going to see a brand new factoring technique right here. So first, let's quickly refresh our memories on how to use the box to multiply 2 binomials, 2 things with 2 terms in them. So multiplying 3x minus 4 by 2x plus 5, I think we've done this one already. So let's fill in the blanks here. The first one is 6x squared. Pause the video for a second, fill in those blanks, and then come back. And so then reading our final answer, just kind of reading everything off from inside of the box. I'll do the first row and then the second row. Well, this one is actually not exactly the same as the one from the previous demo, but it's similar. And then we'll combine like terms. The 2 terms in the middle combine to 7x. So then our final answer is right here. If we distribute through those 2 parentheses, we get 6x squared plus 7x minus 20. Okay, so 2 important facts about the box. Let's multiply these 2 things right here. It's a very strange thing to do, but we'll go ahead and multiply on that diagonal 6x squared by -20. All right, here product equals 6 times -20, that's -120, and then the x squared is just tagging along. And now, since that was so much fun, let's go ahead and multiply the other diagonal and see what we get. So multiplying 15x by -8x. And so I'll put it down here, 15x times -8x. And so we're just multiplying these 2 things here. So x squared for sure. And then 8 times 15, well, it's going to be -8 times 5 is 0, carry the 4. 8 times 1 is 8, plus 4 is 120. So I get -120x squared when I multiply that other diagonal. And shock of shocks, it's exactly the same as multiplying the first diagonal. And this is not a fluke. It's not just a coincidence. It turns out that if you use a 2x2 box to multiply 2 binomials together, the products of the 2 diagonals will always be equal. And we're going to use that fact. It's supposed to be a surprise, but it turns out it's always true. And let's go ahead and continue to focus on the diagonal that I've circled in orange, and let's add those 2 things up. And I'll put that outside of the box here. This one is add, so we'll put sum equals. So if we add the 2 orange ones, 15x plus -8x, that's 7x. Okay, that makes sense. That's actually the middle term that we got right there. So, two important facts about our box. The product of the diagonals are both the same, and then the orange diagonal adds up to the 7x, and that's where we find the two terms that combine in the middle of our final answer. Next page. Now suppose that we are trying to factor 6x squared plus 7x minus 20. Now, we already know what the answer is. Remember, we're trying to factor, which means turn into multiplication. And we just got this answer, right, coming from the previous problem. So where did the previous problem start? Well, it was 3x minus 4 and 2x plus 5. So that's the answer to this problem. Factor this 6x squared plus 7x minus 20. The answer is 3x minus 4 times 2x plus 5. But that was only easy because we had just done the multiplication version of this problem. So we have to pretend that we don't know that we just, we don't have any inside information about this thing. But the question is just, like, where did this thing come from? Okay, well, let's go ahead and take a look at this blank 2x2 box. Well, the 6x squared was in the 2x2 box that we just filled out on the previous page. It was right here in the top left. And the 7x, where did that come from? Well, that came from the sum of the two things on this diagonal right here. The sum of those two things was 7x. I'll put the plus sign in there. And then what about the minus 20? Where was that in the box? Well, that was right here. And then we filled something else out on the outside of this box. We did a product. And we multiplied those two things on the one diagonal that's filled in. 6x squared times negative 20 is, again, negative 120x squared. So all of the things that we just wrote down, we can read or calculate from the original problem, right? 6x squared went in the box, the 7x went outside as the sum, the negative 20 went in the box, and then we calculated the product. So here's the deal about that blank diagonal. Like, we know the answer is supposed to be in the blank. The two blanks on that diagonal is, positive 15x and negative 8x. So we just remember that from the last problem. But assuming we know nothing about what goes in those blanks, we actually have two concrete things we can say about those two things in the blanks. They add up to 7x, and they multiply to negative 120x squared, because the product on both diagonals is exactly the same. All right, so how do we apply that to the problem at hand? So this was the thing we were trying to factor. Remember, we had factored out a 2x originally from this problem way back when. And so let's see if we can start filling in a 2x2 box with the given information. All right, so I know this is already filled in here, but I'm just gonna draw a blank one and start over, even though the answer is right there. So reading the information from that blue highlighted thing, negative x squared, where does it go? It goes in the top left. That plus 4x, where does that go? Well, that goes outside the box. That's the sum of this diagonal. And then where does the plus 12 go? Well, that goes in the box. That's right here. And then the other thing that we could say is that the product on this one diagonal that's filled in, this is just a calculation, negative x squared times positive 12 is negative 12x squared. And so then now we say the two concrete things about the two blanks that are circled in orange there, they add up to positive 4x and they multiply to negative 12x squared. And it turns out there's a unique answer. There's a unique set of things that we can put in those two blanks, each of them having an x, that add to 4x and multiply to negative 12x squared. So the question is, which one of those should we focus our attention on? Well, let's start with the sum. Don't write this. Let's list two things that add up to 4x. For example, 1x, and I'll put a plus sign, and 3x. Again, don't put that. So they add up to 4x. That's great. Do they have the correct product? Well, if you multiply 3x and 1x, you get 3x squared. Sadly, not negative 12x squared. So that didn't work. What if we try something different that adds up to 4x? Maybe plus 2x and plus 2x. They add up to 4x. What is their product? Well, 2x times 2x is 4x squared. Sadly, not the right product. Okay, are there any other things that we can say add up to positive 4x? Well, yeah. What if I told you that one of them was, I don't know, negative 9x? Just making something up. What can I put in the other blank so that the two of them add up to 4x? Well, I think I could put a plus 13x right there. Right? Don't they add up to 4x? What's the product of those two things? Well, let's see. 9 times 13. Of course, I do one I can't figure out. So that's 90 and 27. I think that's 117 with a negative. Negative 117x squared. Is that the product we were after? Sadly, no. Okay, so how many things add up to 4x? How many pairs of things? Well, a lot. Infinitely many. And I don't have time to check them all. So we're not going to start with the sum. We're going to start with the product. We're going to start listing things that multiply to negative 12x squared. So this again is typed out on the side, but let's ignore it and just create it from scratch here. Looking for two factors that have the right product, negative 12x squared. And we're going to do this in a very organized way. I'll start with 1x. What's the partner to multiply by negative to get negative 12x squared? Well, it's a negative 12x. Okay, that was great. How about 2x? How many times does that go into negative 12x squared? Well, it goes in negative 6x times. 3x goes in. How many times does that go in? That's negative 4x. 4x goes in. Negative 3x to get the negative 12x squared. How about, and that is, by the way, different, like these two things here are different, right? The 3x is not the same as negative 3x. The 4s and 3s are the same, but the negatives are in different spots. So those are fundamentally different things, and I've got to write them both. Okay, continuing with my list. I did 1, 2, 3, 4. How about 5? Does 5x go into negative 12x squared? Well, not evenly. And we're never going to put a fraction in any of our pairs here. So that eliminates this from contention. How about 6x? Does that go in? Yeah, it goes in negative 2x times. And there's not many more things that go into negative 12x squared. 7x does not go in. 8x does not go in. 9, 10, 11, 12 is the last thing that goes in. So 12x here and negative 1x there. Okay, so now we are going to figure out which one of these, if any, has the correct sum. We were looking for something that adds up to 4x. I don't know whether or not we found it, but for sure this was a more productive way to list things than listing things that add up to 4x. There were infinitely many things that add up to 4x. If we're just restricted to integers, meaning no fractions, this is a complete listing of all the things that multiply to negative 12x squared, right? There were only 6 pairs of things that multiply to negative 12x squared. Again, each one had to have an x. Okay, let's start adding these things up. So let's do the sum. What do you get when you add 1x and negative 12x? Well, that's a negative 11x. How about 2x plus negative 6x? That's negative 4x. Oh, that's so close. We wanted positive 4x up there in orange. Close but no cigar. 3x plus negative 4x, that's negative 1x. 4x plus negative 3x, that's positive 1x. 6x plus negative 2x, that's positive 4x. That's our winner right there. As soon as you find the winner, you can stop, but I'll go ahead and complete this. Plus 11x is the last one. Okay, so we found our winner. It is right here, 6x and negative 2x. And so we put those two things into the two blanks in either order, 6x and negative 2x. Doesn't make any difference which one goes where. I'll put the plus 6x here and the minus 2x there, but totally okay to swap them. Okay, that is the hardest part of this process, is finding the two things that go in the blanks. Next up, we're going to look at the first row only. I'll highlight it here in yellow. And we're going to pull out the greatest common factor, and we're going to write it here in the front. So what is the greatest common factor of negative x squared and negative 2x? Well, they're both negative, so I suppose I'd like to say that the negative is part of the greatest common factor. The biggest number I can put into both of them is actually just a 1, so I think negative 1 is all we can do there, but they also both have an x in them, and so negative x is the greatest common factor. Now we are going to put something outside of this blank right up here. And I caution you, we are not looking for any more greatest common factors, not doing the greatest common factor of the second row or the first column or the second column. We're just doing one single greatest common factor in the first row and then changing fundamentally how we find the other 3 blanks that go outside the rectangle. We know that this thing here multiplied by whatever I put up here is supposed to give me negative x squared. So now we're just little detectives trying to figure out what to put there so that it couples with this and gives me what I want, the negative x squared. So hopefully we see that the thing we need up here is an x. If you multiply those two things outside the box, you get negative x squared, which is exactly what we wanted there in green. Let's move over to the top right. I know that this negative 2x was supposed to be the product of this guy way over here and whatever we put. So what do we need to put right up here? Well, let's see. The negative is taken care of. The x is taken care of. What isn't taken care of is the 2. So it's got to have a 2 up here. Again, I'm going to try to do my best to remember to put plus signs. Signs on everything. And again, you can check to make sure that we got the right thing out there. Negative x times positive 2 indeed is negative 2x. And then the last blank is right here. I know that this 6x on the inside is the product of this guy way up here and this blank way over here. So what do I get? What do I need to multiply these two things and get positive 6x? Well, the x is already accounted for on the top, so I think it's just the positive 6 we need. So we put a plus 6 right there. And then we've got no more freedom, no more blanks to put, to fill in. But the plus 12 we have not checked, and we better make sure and cross our fingers that indeed we get plus 12. Well, look, plus 6 times plus 2 is plus 12. And if you follow this process correctly, you'll always get the right thing, the correct thing in the bottom right box. But if you got something different, you know, like if this had been a 7, and you do the 7 times the 2 and you get 14, you say, uh-oh, I made a mistake somewhere. I don't know where that mistake is, but go back and try to find it. It will work if you do this correctly. Okay, and now I think we're good to go. Let's take a look at this thing we've got up here in blue. This guy is equal to 2 new sets of parentheses. I'm going to copy the thing on the left-hand side of the box that we just filled in, negative x plus 6, and then the thing on the top of the box, x plus 2. And then the only piece that we're missing here, the very first step of this problem was to factor out a 2x. That was the greatest common factor initially. It doesn't go anywhere, it just sits there right in the front. So that is the completely factored version of the original negative 2x cubed plus 8x squared plus 24x. Okay, on the next page, lots of details, lots of arrows. Ultimately, we get exactly what we just said, I think. Negative x plus 6 and x plus 2. Yeah, perfect. Okay, so number 21, I mean, this is a long process, but with practice, using a 2x2 box to factor becomes easy, but it's tough at first. Persevere. That said, you need not use the box on any test problem. The important thing is that you are able to factor using some method. It doesn't matter how you get to the factors. Some people do a trial and error, and that's totally cool. As long as you get to the correct factors, I will be happy. That said, some of you have a lot of experience with factoring these kinds of trinomials in some past math class, and you might have some shortcut in your mind that says, oh, I just need 2 things that have this product and this sum. I caution you against using that. It does not always work, but the box always works. So I encourage you to use the box on at least half of the problems in this activity and at least half of the homework problems. It's possible that if you have a shortcut from some previous math class, that it's going to work all day today or maybe most of the activity today, but that it's all going to fall apart in the next class. So use the box, even if it's longer than the technique that you have from some previous math class. Last thing here is 22. The following template may help you keep track of the order in which you should be filling things in when using a 2x2 box to factor. So let's go ahead and copy the original problem, just the part that we were working on. We'll do this thing again quickly. So negative x squared plus 4x plus 12. So you can see these little numbers that I've put in here. They're telling you the order in which you're supposed to fill things in this template. So 1, 2, and 3 are the things that were given in that order. So we put them in the box in that order. Number 1 is the negative x squared. That goes in the box labeled 1. The second thing up there is plus 4x. That goes where this 2 is, which is where the sum is. Plus 4x there. The third thing given is that plus 12. That goes in the box with the 3. The fourth thing to do is calculate the product of the diagonal that we know. So we multiply that diagonal and we get negative 12x squared. The fifth thing, well, there's 2 boxes with 5s in them, and the fifth thing is the hardest step. This is the part where we play detective and look for 2 things that have a sum of positive 4x and a product of negative 12x squared. We did a lot of work to calculate 6x and 2x, so you put them in the box. Doesn't matter what order, but they both go in at the same moment. Okay, looking at the 6th thing, which is right here, it is the greatest common factor of that first row, which we said was negative x. And then the seventh thing is not a greatest common factor. The rest of the things outside the box, we're just looking to figure out what do we need to put out there to multiply and get the things in the box. So I think we figured out seventh thing there was an x, eighth thing is a +2, ninth thing to get that 6x, we just needed the +6, and then we had our answer reading from outside the box. So the template is not going to be provided on tests or quizzes, but if it's helpful to you, feel free to use it. It is provided on today's activity.